A rectangular sheet of 36 centimeters of dimension x centimeters by y centimeters is to be rolled into a cylinder as shown with the height y centimeter, the same height of the rectangular sheet. What values of x and y give the largest volume? We're looking for the largest volume. In other words, we want to maximize the volume of the cylinder. The volume of the cylinder is pi r squared h. We don't know if we need it, but since the volume is what we're trying to maximize, we need to come up with the equation. This equation has several variables, but as of now, this is the volume of the cylinder. We will need to rewrite it later. With the constraints that the perimeter has to be 36, the perimeter of the rectangle is 2x plus 2y. Ideally, we want to rewrite this volume or the objective equation in terms of x or y only. And in this case, since y is the height of this cylinder, we want to rewrite everything in terms of y. So the volume is pi r squared y. We now need to find a way to express r in terms of y. But this cylinder has the circumference at the bottom being 2 pi r, where r is the radius of the circle. The length of this circumference 2 pi r needs to be the same as the length of the rectangle, which is x. So 2 pi r has to be x. R is therefore x over 2 pi. So we replace the volume with pi times r squared is x over 2 pi squared times y. Simplifying this, we have pi times x squared over 4 pi squared times y, which is 1 over 4 pi x squared times y. But again, this is still not good because we still have two variables, x and y. Using the constraint, 36 equals 2x plus 2y. Divided by 2 from both sides of the equation, we have 18 equals x plus y. In this case, it is easier to isolate y in terms of x because y is by itself already in the volume. So y is 18 minus x. We now have the equation of the volume, the objective equation in terms of x only, 1 over 4 pi times x squared times 18 minus x. We can think of this as f of x equals 1 over 4 pi x squared times 18 minus x. The word problem now reduces to finding the maximum value of this equation, this function. From the constraint, we see that the smallest x value can be is 0 and the largest that x can be is 18. The reason x can be 18 the largest is because even if we start out with a degenerated rectangle, we still need to have two lengths. If the length is 18, the two lengths is 36 already. The maximum x can be is 18. So the question again reduces to finding the absolute maximum of the function f of x equals 1 over 4 pi times x squared times 18 minus x on a closed interval, and we guarantee to find such absolute maximum at either critical points or endpoints. That is why we now find the critical points. F prime of x is, using the product rule, we have Derivative of 1 over 4 pi x squared is 1 over 4 pi times 2x, and we keep the second factor using the product rule, plus x squared over 4 pi times derivative of the second factor, which is negative 1. This is 2x times 18 minus x over 4 pi minus x squared over 4 pi. We then set it equal to 0, but to do that, we would factor out x over 4 pi only. The first term end up with 2 times 18 minus x, and the second term we end up with x only. This is x over 4 pi, 36 minus 2x minus x, and this is x over 4 pi times 36 minus 3x, and we set it equal to 0. This derivative is 0 when x is 0, or when 36 minus 3x equals 0, or 3x equals 36, or x equals 12. X equals 0 is an endpoint, x equals 12 is the critical number, and x equals 18 is another endpoint. We set up the table for the endpoint and the critical points. 0, 18 are the endpoints, and 12 is the endpoint. And we plug this into the volume function, where the volume is x squared over 4 pi times 18 minus x. If we plug in 0, then the volume is 0. If we plug in 18, the volume is 0, because 18 minus 18 is 0. If we plug in 12, we have 12 squared over 4 pi times 18 minus 12, which, whatever that is more than 0 for sure. Thus, to maximize the volume, we would need the length x to be 12, and if the length x is 12, with the parameter is 2x plus 2y, we see that 36 equals 2 times 12 plus 2y. So 2y equals 36 minus 24. Y is 36 minus 24 is 12. 12 over 2 is 6. We would need to have a rectangle in the dimension x equals 12 and y equals 6. This parameter is 36, and it will give us the largest volume for the cylinder. We don't need to find the volume in this case because the question only asks for the values of x and y, and we found them. If we want to find the volume, we just simply plug this into the volume, which is pi r squared h, but there's no need to. The volume function is x squared over 4 pi times 18 minus x, where x is 12. So we simply evaluate this expression to get the exact volume if needed.